Sharks are known today as some of the most diverse and successful groups of not only aquatic animals, but of all known life in general, with the true sharks in the clade Selachimorpha having an extensive fossil record. The term shark, however, is not a means of taxonomic classification, as Chondrichthyes or cartilaginous fish and their ancestors themselves have been around since the Silurian and possibly even the Ordovician for at least 420 million years, and have adapted to a range of ecological niches and developed a wide set of body plans. The true sharks are instead much more recent animals. There are many other animals that, while often referred to as sharks, are actually, while closely related, belong to the wider subclass of Elasmobranchii, which means that they are placed outside of the clades that includes the true sharks, with notable examples being animals like Cladoselache, Xenacanthus, and various other members of the wider Chondrichthyes class, like the holocephalians, which produced varied forms like the famous Eugenedonts, which are distant relatives of the bizarre Chimaeras rather than true sharks. One of these groups is the extinct order known as the Ctenacanths, which are notable for possessing ornamented fin spines and cladodont's multicusped dentition, with members of this group potentially surviving into the early Cretaceous. The holotype of the animal, which will be covered in this video, was discovered at the Kinney Brick Quarry Lagerstätte in the Manzanita Mountains east of Albuquerque, New Mexico. This site dates to late Pennsylvanian or late Carboniferous from around 307 to 303.7 million years ago, being more specifically dated to the Castamovian, the third stage in this time period, corresponding to the Masurian in North American geochronology and the Stephanian in Western European geochronology. The holotype was discovered by paleontologist John Hodnett, who, while during a paleontological conference day trip to the Manzano Mountains in May 2013, came across the tip of the nose of some kind of animal. The animal was exposed on its right side in a fine-grained limestone, with Hodnett using a pocket knife to sift through the sediments, with the first fragments he identifies looking like a piece of limb bone to him, which struck him as unusual because although the region is well known for fossils and plants of animals from the Pennsylvanian period, they rarely get so large. While it ended up not being a tetrapod, as was found out later, it certainly was a fairly large animal and would prove to be quite the impressive find. Eventually identified as some kind of fish due to the size of the fossil present, it was removed in 3 sections to be preserved and reassembled in the paleontology laboratory at the New Mexico Museum of Natural History and Science. It took a further 7 years of research to identify the animal and catalogue its various characteristics, with it garnering the name of Godzilla or Godzilla shark in reference to the undescribed animal's unusual features, including their 12 rows of teeth, short face, and the 2 very distinct spines on the back. It also went by the more tame name of the Manzano Ctenacanth in reference to where it was found, although it would be eventually described and named after a lengthy period of identification and research. The specimen was named as Dracopristis hoffmannorum, Hoffman's dragon shark, the species name referring to the Hoffman family, who owned the land on where the shark fossils had been collected, and is most definitely one of the most important and notable fossils found in the region. The skeleton was exceptionally well preserved, the reasons as to why will be discussed later, with the specimen itself being 6.7 feet long, or just over 2 meters, medium size for the group overall, with it being approximately 85 to 90+% complete, revealing quite a lot about how they would have appeared in life. This is in fact one of the, if not the best preserved Ctenacanths ever found. Before Dracopristis was described, Ctenacanth fossil remains range from the conspicuous spines to their uniquely cusped teeth to amazingly complete skeletal remains, although these were more often than not few and far between. The specimen of Dracopristis preserves the body, pectoral, pelvic, caudal, anal, and both dorsal fins, as well as their integuments in the form of their dermal denticles and soft tissue, all in complete articulation. Their dermal denticles are of the typical Ctenacanth morphology, with at least 4 types being identified. Type 1 and 2 are noted to be rectangular, thin-walled, and recurved with triangular ridges, which were collected from regions behind the cranium, and becoming broader dorsoventrally near the tail, with the Type 2 denticles having the ridges slightly thicker and raised. Type 3 denticles have numerous bulbous cups, and are much thicker than Type 1 and 2. Type 4 denticles are round, with ridges radiating from the central region, with these 2 only being collected from the cranium, likely for reinforcement. The tooth cusps are also distinct from those of all other Ctenacanths in their proportionally shorter height and broad triangular shape. A juvenile tooth fragment, which has also been described, also shows a relatively short cusp height, although it does differ from the adult dentition in having rounded cusps, quite different from the tall cusps that are evident in other related animals. Their jaws also differ in being proportionally deep, robust, and posteriorly shorter than seen in other Ctenacanths, which as a whole differ from true sharks in that Ctenacanths' jaws are proportionally larger and less flexible, with their shorter and wider teeth being more useful in grasping and crushing prey rather than for piercing. The specimen is also so well preserved that it is actually possible to identify the animal's sex, as with the whole body being intact, no clasp or cartilages were found to be present, meaning that this particular individual was a female. Dracopristis is so complete that even its habits and habitat preferences can be assumed based on their morphology. They possess large pectoral fins, and alongside the lower lobe of the caudal fin which sticks straight out, inferences about their niche can also be understood. This morphology is most often attributed to extant sharks that tend to be slow-cruising pelagic and or benthic sharks, which utilise this fin type for accelerating or manoeuvring. Such caudal fins are seen in angel sharks, which utilise ambush strategies for hunting prey, with this seemingly marking the first known benthic specialised Ctenacanth. Dracopristis may therefore have been a coastal estuary specialist, similar in regards to some Eugenedonts, Elasmobranchii, such as the bull sharks or common sawfish, with their body form also being craniocaudally elongated and dorsiventrally narrow. The environment of the Kinnibrick Quarry was unique in that it represents and preserves an area of bays and lagoons with plenty of terrestrial influence, with the locality representing an estuarine lagoon deposition with brackish shallow waters. The area was formed through a structurally controlled embayed shoreline, which led to tidal amplification, with Seton Bay's coastline protecting the environment from storm wave influence. The Bay Head's delta near the region also supplies nutrients to the embayment, which would have resulted in brackish conditions forming, which at certain depths would have created anoxic bottom water conditions through restricted circulation and poor mixing. These conditions meant that even if animals like Dracopristis, animals with their cartilaginous skeletons rarely preserve well, fell down to these layers once they had died, they would not be scavenged due to the anoxic zone keeping said animals out, and would therefore be buried by fine-grained silts over time, with little damage done to the body, as has been the case with Dracopristis and other such fauna and flora. There were also other animals Dracopristis shared its environment with, which came in a wider range of sizes, with evidence of large, elasmobranchii Ctenacanths like the ubiquitous and long-lived Glycomanius, currently only known by their teeth, being present, although it's been suggested that there would have been occasional marine visitors rather than residents. The size of the teeth indicates that this genus was the larger of the two Ctenacanth taxa, being estimated at about 3 to 4 meters in length based on said tooth dimensions. Ctenacanths are overall though a rarer component of the Chondrichthyes assemblage in the area, with other animals including a small hybridont, a Xenacanth, a Petallodont, and a holocephalian, with them being outnumbered considerably by the much smaller Acanthodes and Actinopterygians, or ray-finned bony fish, which would have been the main prey for the larger Ctenacanths. There's also another notable animal that was more than likely an occasional visitor to the area, but is notable nonetheless, that's being individuals of the Eugenedonts Campiloprion, a very early cousin of the famous Helicoprion, which could have reached sizes of 5 to even 10 meters. As such, this is where the notable and arguably most distinctive feature of Dracopristis could have been utilised, that's being their large dorsal fin spines. Other Ctenacanths also possess said spines in front of their dorsal fins, although the ones in Dracopristis were proportionally incredibly large, and could very well have been used as a deterrent to larger predators, with said spines being 57 centimeters long, approximately 27% of the total body length, with them being 5.3 centimeters wide and being distally recurved. Overall, the completeness of the Dracopristis holotype allows for said specimen to be used to potentially determine the missing data of other, more incomplete Ctenacanths around the world, which could go a long way in understanding more about these peculiar animals. All in all, I thank you for watching this video on these animals, and that you may have learned something new. If you would like to see more from this channel, be sure to subscribe if you haven't already, and with that, I'll see you next time, whenever that may be.